So we just finished watching a video on a linear inequality in two variables, and now we're going to be talking about systems. So we're going to be looking at two or more at the same time. Now I'm just going to stick with two lines, and they are going to be lines and not circles or ellipses or parabolas here. So again, the Board of Regents wants us to show you systems, and we're going to keep it short and sweet given where we are in the semester. So the only difference here when we start out is to look at these one at a time. But we're going to graph both lines on the same set of axes. So if we look at y equals 2x minus 1, we would have a y-intercept of -1, and then we go up 2 over 1, up 2 over 1, or down 2 and left 1, and we do this all day long. So we have enough points. I'm going to use my chalkboard magic here to draw that line, and hopefully it'll cooperate and turn colors that I want it to turn. Okay. Also, and I'll pop back in there in a minute, but if I need to, but because it says I can be equal to those values, remember we connected those dots with a solid line. Now, if we want to check an ordered pair and see which side of that line we're supposed to shade, and my favorite point is the point 0, 0. So if I plug in 0 for y and 0 for x, that says 0 is less than or equal to -1. And I say, well, that is not a true statement. And so instead of shading above this line, I'm going to shade below it. And I'm going to use a highlighter. So any ordered pair to the right side or below, we could say this line is part of the solution set to that top equation. Okay, we're just working with the top equation so far. So if I pick the point 4, 0, or 4, -4, or 2, -5, or anything over here, it'll make that top equation true. Now, next, I'm going to sketch a graph of the line y equals -x plus 3, which means I have a y-intercept of +3 and a slope of -1. -1 means down 1 and right 1, or up 1 and left 1. And again, I'm going to use the chalkboard magic here to draw the equation, or to connect those dots. Now here, when I look at the symbol, remember when we just had a less than sign or just had a greater than sign, then we're not going to connect those dots with a solid line. We're going to make that line dotted when we sketch it on the graph. That indicates to the reader that as we shade one side or the other, we know that we can go clear up to that line, but not actually step on any of these purple dots that I have that make up the line y equals -x plus. Okay. Next, I'm going to stick with my ordered pair 0, 0. Again, as long as my line does not pass through that point, I can use that as a checkpoint to see whether or not it makes a true statement. 0 is not greater than 3, so I will not shade this side of the purple line either. I will have to hop across and shade above the purple line. Let's see what colors of highlighters I can choose from. I've got a pink. I'm not handed in a way that I can easily do that, so there we go. Now with our system of inequalities, just like with our system of equations, we're looking for the ordered pairs that satisfy all of the equations or inequalities in our system all at once. Okay, so when we were just looking if these had equal signs, instead we'd be looking for this single point of intersection right here. Okay, now with our inequalities, we are going to be looking at the shaded region that is shaded by both colors. Okay. So our solution set are all of the ordered pairs that have turned kind of blue color here. I can use any ordered pair on this line, clear down until we get to this point of intersection, but we cannot actually use the points on the purple line here. Okay, so anything up to and including this blue line, but up to not including that purple line in this area. Okay, when you are marking these for me on a homework quiz or test, you can draw arrows there, you can shade it in a way, maybe leave me a color code that says the red area is the solution set every time. Okay, you can put a star here or draw an arrow. Okay, again, as before, you need to make sure that whether you have a solid or a dotted line is clear to me by what you've written on your paper. And if it was supposed to be dotted and you made it solid by accident and you don't have means to erase it or make that clear, just leave me a little note that says this line is dotted. And I'll know that's what you intend. Okay, so just like always, the only way to create a problem that's any harder than the one we just completed is to create a problem with more steps. And these are steps that we did in the last video, but we get to repeat them here, and there's two inequalities instead of one. So the first thing is I need to solve this inequality for y and solve that inequality for y so I can get it in slope-intercept form. Then I can sketch both graphs up here, paying attention to whether my line should be solid or dotted, be from the symbol. Then I'm going to check points in both inequalities, and I'm going to shade the points where they overlap. Go ahead and pause the video here and work through that as far as you can. I'll have some checkpoints along the way, and you can turn it on to see if you're right. When you solve these two inequalities for x, here are the two lines that you'll be graphing. Don't forget that when we divide both sides in this step by -2 to flip the direction of the inequality symbol. Okay, less than goes to greater than. If you made a mistake there, then when you did your checkpoint, again, checkpoints are always safest to use in the beginning equation. Hopefully you would catch your error at that time if you made one. Okay, so if you weren't here, get your equations or your inequalities adjusted to here. Now sketch your graphs, solid or dotted, figure out where to shade, and find where they overlap. So when we graph the first line over here, this is the blue one. This one's the purple one. Make dotted lines here, solid lines here. I picked the ordered pair 0, 0, and when I plugged it in to both original equations, I get two true statements. Again, if I plug it into these steps, I should also get two true statements, but if I made a mistake here, I would think this one was false, and I might shade the wrong side of the line. So it's always safest to go back to the beginning. Okay, I'm going to pause again to shade and then turn it back on when I'm done. Okay, so I am below the blue line, I'm above the purple line, and so my solution set would be in this blue shaded region here. Okay, this one being solid and this one being dotted. Here's one more for you to try. When you turn the video back on, I'm going to have the whole thing here from beginning to end. So work through it as far as you can. Try to get all the way through before you turn the video back on. Okay, so the line. Sorry, easily distracted. This first line here is y is greater than 3/4 x minus 6. This one, when we solve for y is less than -x plus 5. And negative slope, 5 as the y-intercept. Solid line here. Oh, what did I do? Not a solid line on the blue one. It was supposed to be dotted as well. Got in a hurry. So two dotted lines. I don't know if I can wiggle things around to where they're in the wrong place now. But our solution set, they both overlap. It's a circle right here, or this region right here. Two dotted lines, a shaded area in between. Get a hold of me if you have questions and need help with more of these. Thanks.